Good evening, ma'am.
Good evening.
Good evening.
Hello. Good evening, children.
Good evening, ma'am.
Good evening, beta. How are you? Good evening.
How are you, ma'am?
I'm good. Turn on the video, everyone. Yes, Nishika, Adya, turn on the videos. Okay, in the last class, we were doing understanding elementary shapes, right? Yes. So we have little more left in that. Let's finish with that. Nishika, you had your exam, maths exam.
No, ma'am, not yet.
When it is? When is the exam?
Ma'am, February 6th.
February 6th. Okay.
Yes, ma'am.
Ma'am, my maths exam is on February 2nd, ma'am.
February 2nd, right?
Oh, sorry, I'm third.
Okay. Okay. So, Nishika, you had given some topics for revision. Hello, Nishika.
Yes, ma'am, I didn't understand some chapters.
Okay. So, do you want to do that in the class right now?
Yes, ma'am.
Okay. So, we'll have to leave the chapter in between now then. Understanding elementary shapes. Hmm.
Ma'am, then we can do it next class tomorrow.
In the next class tomorrow.
Yes, ma'am.
Okay, we'll do one thing. We have only a few topics left in this chapter. Soon we'll try to finish it. Okay. And then we'll take up your topic. Yes.
Yes, ma'am.
Okay. And then tomorrow yours only. Whatever topics you have given, it will benefit everyone then. Okay. Right.
Yes, ma'am.
So let's finish this chapter first. Okay. I'm sharing the screen. Okay, now see, in the last class, we were discussing about perpendicular and perpendicular bisectors, right? So perpendicular lines are those lines which intersect and the angle between them is 90 degrees. Okay, perpendicular lines are those intersecting lines which make the angle 90 degrees between themselves, right?
Ma'am, which chapter do we have for the Sunday test?
Integers.
Okay, ma'am.
Okay, I've given integers. I gave the message
Oh, yeah, okay, ma'am. I actually didn't
yesterday.
get it, ma'am.
Yesterday I gave the message.
Okay, ma'am.
Okay, so these are those intersecting lines which make 90-degree angle between them. And the symbol for perpendicular is like this, right? So you can see here also AB perpendicular to CD. It's written like this. So this is the symbol that we use for perpendicular lines. And there is one more term that you studied, that is perpendicular bisector. Perpendicular bisector is making 90-degree angle between the two lines. At the same time, those two lines are divided into equal parts. Okay, like suppose A to O is equal to O to B, and similarly C to O will be equal to O to D, right? Okay. So CD will be divided into two equal parts by this AB line. At the same time, this AB line will also be divided into two equal parts by CD line, right? And moreover, the angle between them will also be 90 degree. So that means perpendicular means 90 degree. Bisector means bi means two. Okay, sector means making it a section. Okay, bisection, making it into two equal parts, two different parts. Okay, so let's see this. Which of the following are models for perpendicular lines? So if we take the adjacent edges of a tabletop, will that be a perpendicular line? If you see your tabletop, the corner, are the two edges making perpendicular?
Ma'am, your screen is not visible.
Is it? Yes, children?
Ma'am, it is visible now.
It's visible.
Yes, sir.
Adya, please check yours better. To everyone, my screen is visible. Neha, Trilokya, Nishika. It's visible.
Yes, ma'am.
Then, Adya, you please check yours better. Okay, so when you see the adjacent edges of the tabletop, you can see, are they at a perpendicular? Just see, if you see the edges of your tabletop is rectangular or square? So what do you see like this? Your tabletop is something like this. It may be a square, it may be a rectangle. So the edges are like this. That means it's making 90-degree angle.
Yes, ma'am.
Yes, no? Okay, now let's see the lines of a railway track. Now railway track lines are like this. Is it perpendicular? Yes.
Yes.
No, ma'am, they are parallel.
No, they are parallel. Line segment joining line segments forming the letter L. Now, if I have two line segments making letter L, are they perpendicular?
Yes.
Yes. Okay. The letter V, are these two lines perpendicular? If I make one line like this, one another like this, are they perpendicular?
No, ma'am.
No, they are not. Okay, so let's see question number 2. Let line segment PQ be the perpendicular to the line segment XY. Okay, so this PQ is perpendicular to XY. Let's take PQ and let's take XY here. They are perpendicular. Let PQ and PA XY intersect at a point A. Okay, so this point of intersection is A. What is the measure of angle PAY? So what is PAY measure? This, it's saying that PQ is perpendicular to XY. So what is this angle measure?
90 degrees.
90 degrees. Okay, because perpendicular is 90 degrees. Right angle. Okay, let's see the next question. I want somebody else to read the question. Shreyansh, you read the question number 3.
Okay. There are two set squares in your box. What are the measures of the angles that are formed at their corners? Do they have any angle measures that is common?
So it's saying there are two set squares in your box. Yes?
Yes,
In your geometry box, you can see two set squares.
yes, ma'am.
What is the measures of the angles that are formed at their corners? So just check what angles are they forming at their at the corners. See, one angle in both the squares is the right angle. Yes. In both the set squares, one angle is the right angle. Then you have to find the other two. Now see, one set square is like this. Yes. Another set square is like this. Yes. So you see 90 degrees there in both the set squares, right? But what do you see here? In these two, one of the set square, you can see check the length of these two sides. In one set square, one side is longer and the other side is shorter. But in another set square, the two sides are longer, of equal size. Just check which set square has equal sides. The two equal sides, the arms of the angle. Yes? See? Show me. Yes. Good. So this one has two equal sides, no? Okay, so that means if these are two equal sides, that means these two angles will also be equal. Okay. Suppose the sides are equal, then their opposite angles are also equal. So this set square has angles 90 degrees and the angle sum property is 180 degree. All the angles of a triangle is 180 degrees, right? So if one angle is 90, that means the remaining two are what? The sum of the remaining two are also 90 degrees. Yes, then only it will make 180, no? 90 plus 90. So that means the other two angles are 45 degrees and 45 degrees, right? Are you understanding? 45 plus 45 is 90 and this 90. So 90 plus 90 is 180 degrees. So that gives you the angle sum property, sum of the angles of a triangle. So one set square has a measure 90, 45, 45 degrees. Another set square has the measure, this is 90 degree. Okay, then this one is 30 degrees. Then this is 60 degrees, right? You can check with your protector also. Okay. So that means the measures of the set square are 90, 30, 60 and 90, 45, 45. Right? Yes, children?
Yes,
ma'am.
I hope you are understanding this.
Yes, ma'am.
Let me just write it clearly to you. Okay, so this is set square is 90, 45 degrees, 45 degrees. And other set square is 90 degrees, 30 degree and 60 degree. These are the two set squares. Okay, let's see question number 4. Study the diagram. The line L is perpendicular to line M. Oh no, these are two lines are given. This is line L. This is line M. Is CE equals to EG? CE is here from C to E and E to G. Are they equal? Just check out. I'll be asking each one of you. Does PE bisect CG? Now see where is PE. P is here. PE bisect CG. So you have to answer all these questions. Just analyze the figure, read the question and analyze the figure. I'll ask you. Okay, so is CE equals to EG? Yes, tell me. Trilokya, you tell me.
Yes,
C to E and E to G. Are
Yes.
they equal?
Yes,
Yes. Okay. Does PE bisect CG, Shreyansh?
Yes, ma'am.
Okay, PE is here and C to G is here. It's bisecting. Bisecting means dividing into equal parts. Okay. Identify any two line segments for which PE is the perpendicular bisector. For which PE is a perpendicular bisector. Identify two line segments. So, Neha?
Ma'am, DF and CG.
DF and
CG.
CG. DF and CG. Okay. Right? Children, are these true? Now see what is true. AC is greater than FG. AC is greater than FG. Nishika, yes, tell me. C, A to C is what distance and F to G is what distance?
Mom, it's true because A to C is 1 to 3, and then F to G is 6 to 7.
Yes. So 1, 2, 3 means it's 2 units, no? Okay, you can take it even centimeters. See, this is 1 centimeter, this is another centimeter. So in total, it is 2 centimeters. And this
Yes.
is just 1 unit from 6 to 7. That means 1 centimeter. Right? So this is 2 centimeters, this is 1 centimeter. Okay, next CD is equal to GH. CD is equal to GH. Adya is here. Yes, Adya?
Yes, ma'am.
Tell me, is CD equal to GH?
Yes, ma'am.
Okay. Next, BC is less than EH. Yes, Adya, tell me. True or false?
Yes, ma'am, true.
Okay. Okay, next is classification of triangles. See this, you have studied in your junior class also that we classify triangles on the basis of their angles also, on the basis of their sides also. Yes. So on the basis of their sides, we have scalene triangle which has all the three sides different measure. We have isosceles triangle which has two equal sides, right? This one. We have equilateral triangle which has all the three sides equal. Okay, so this is the classification based on sides. And if we have to classify on the basis of their angles, then we have acute angled triangle in which all the angles of a triangle are acute. That means all the interior angles of a triangle are acute. Okay, less than 90 degrees. And if we talk about right angled triangle, in this one angle of a triangle is right angle. The other two may be different, but one is the right angle. Okay, one angle is the right angle. Then we have obtuse angled triangle. Obtuse angled triangle means one angle in a triangle is obtuse. Okay. Yes. Hello. Understood everyone?
Yes,
Okay. Now let's see this. Name the type of following triangles. Triangle with lengths of side 7, 8 and 9 centimeter. Okay. Name the type of triangle. So tell me what type of triangle is it?
ma'am, scale triangle.
Scalene triangle. Next, triangle ABC with AB 8.7 centimeter, AC 7, BC 6. What type of triangle is this?
Ma'am, scale.
Scalene. Triangle PQR such that PQ is equal to QR equals to PR equals to 5 centimeters. Yes, which triangle is this? Equilateral. Good. Triangle DEF with measure of angle D equals to 90 degrees.
Right angle.
Right angle, very good. Triangle XYZ. See, anyone can answer in this. I'm not taking anyone's name. Okay, anyone can answer. Triangle XYZ with measure of angle Y is 90 degree and XY is equal to YZ. Which triangle is this?
Right angle. Right angle.
Right angle. Right angle and it's isosceles also. Okay. Now triangle LMN with angle L is 30, M angle is 70 degrees and angle N is 90 degrees. What type of a triangle is it?
Scale.
No, beta, angles are given. Scalene are the sides. These are angles given. This is acute.
Acute angle, obtuse angle, obtuse angle.
So this is acute angle. Okay. Because you can see all the angles are acute in this. So it's acute angled triangle. Okay, now, okay, this we have already done. Let's move further. We are quickly revising so that we can take another topic. Name each of the following triangles in two different ways. Okay, so you have to name it in two different ways. Now see this first one. You can see all the sides. Okay, the two sides are of equal measure. Yes. So we can call it as isosceles triangle. Yes. And we can see that two angles are equal. Yes, two sides are equal and two angles are equal. Okay, this is isosceles only. Another thing is that what else we can say? All the angles are acute, right? So we can call it acute angle triangle also. Yes, we can do that. Similarly, you can try for this one. One angle you can see it's 90 degrees and the rest of the sides just check out. What can you say? Yes, it's scalene also and it's right angle also, right?
Yes, ma'am.
Okay, next one.
Isosceles and obtuse.
Yes,
Isosceles, obtuse angle.
isosceles and obtuse. Okay, this is obtuse and since two sides are equal, so this is isosceles also. Now, debit. Yes,
Isosceles and right angle.
isosceles and right angle. Okay, next one.
Equilateral triangle, acute angle.
Okay. Next one.
Scalene obtuse.
Scalene and obtuse. Good. Okay, this is a matchstick pattern. So, okay, let's see further. We have now quadrilateral. So, quadrilateral, as I have told you, quad means four. Okay, lateral means side. So, any four-sided figure is called a quadrilateral. It can be a rectangle. Okay, it can be a square. It can be parallelogram. It can be a trapezium. It can be a rhombus. Right? It can even be a kite. Okay. So, quadrilateral is that figure which is made by four line segments. So, you know the properties of square, rectangle. Okay. Let's see. Okay, let's see. First learn the properties. Let's check out the properties of these. Now, in a rectangle, you know that the opposite sides are equal. Yes. One pair, two pair of opposite sides are equal. This side is equal to this side. This side is equal to this side. In a square, you know that all the four sides are equal. Right? In a parallelogram, the opposite sides are parallel and equal. Okay. and one set of side is parallel and equal, another set of side is parallel and equal, right? Okay. Now in rectangle you can see all the angles are 90 degree. In square also all the angles are 90 degree. But in parallelogram, see parallelogram had the same properties of a rectangle, right? That opposite sides are parallel and equal. But thing is that here the angles are not 90 degree. The opposite angles are equal. This angle is equal to this angle and this angle is equal to this angle. Okay. And similarly, there are differences between their diagonals also. Okay. In a rectangle, the diagonals are equal. In a square, the diagonals are equal also and they are perpendicular bisectors also. But in parallelogram, the diagonals are not equal. Okay. They are bisectors, but they are not equal. Okay. Now, if you see about trapezium, this is a trapezium figure. In trapezium, only one set of opposite sides are parallel, just parallel, not equal. Okay, they are only parallel. And the other pair is non-parallel. Right? Okay, then you have the rhombus. The rhombus, you have all the four sides are equal. Right? And if you talk about the diagonals of a rhombus, they are perpendicular bisectors. Okay, the diagonals make 90-degree angle between them and they bisect each other. Okay. So rhombus also has diagonals as perpendicular bisectors. Square also has diagonals as perpendicular bisector. Rest in parallelogram, the diagonals are bisectors, not perpendicular. In rectangle also, the diagonals are bisectors. Right? Let's see some questions in this. True, false. Okay, each angle of a rectangle is a right angle. Is it true? Okay, yes. The opposite sides of a rectangle are equal in length. Is it?
True, ma'am.
True. The diagonals of a square are perpendicular to one another.
True, ma'am.
The diagonals, what is it written? The diagonals of a square are perpendicular to one another. Okay. All the sides of a rhombus are of equal length.
True, ma'am.
True. All the sides of a parallelogram are of equal length. False. Okay. Okay. Next is the opposite sides of a trapezium are parallel.
True, ma'am.
True. Okay.
Ma'am, but only one pair of opposite sides are parallel.
Opposite sides of a trapezium. So one pair of opposite. No, it's not written that all. Opposite sides of a okay, we'll take it false. It's not so clearly written. Okay, we'll take it false. Only one pair is. Okay. Okay, Trilokya?
Yes.
It's better if we take false. Opposites. It's written opposite sides. Sides means all sides. You're right. Okay, give reason for the following. Okay, a square can be thought of as a special rectangle. Yes? Can we take square as a special rectangle?
No,
Yes?
no, I guess.
It's a special rectangle only, no?
Yes, ma'am, but the sides are equal.
Sides are of different measure, no? Yes, we can take it. Yes. Okay. Because in square, we see that all the sides, in square, we know all sides are equal. Okay. And rectangle also says that the two opposite sides are equal, like this. And when we talk about its area or perimeter, so perimeter is sum of all four sides. So this is all sum of four sides, right? But only thing is that it's this measure, the length measure is different in this. Okay, so square is a special type of rectangle only. Okay. Next one, what do you think about this? You have to give reason. A rectangle can be thought of as a special parallelogram. Yes? Can we take rectangle as a parallelogram? In parallelogram, what do we see? That
Yes.
the opposite sides are parallel and equal, right? So this is also a special parallelogram. A square can be thought of as a special rhombus. Yes? Can we take that? A rhombus has its all sides equal.
Yes, ma'am.
Okay. So square also has the same properties, only difference is the angle. Okay, square, rectangle and parallelogram are all quadrilaterals. Yes, they are all quadrilaterals, four-sided figures. Square is also a parallelogram. Can we say that? Square, if we say, if we can say square is a rectangle, special type of rectangle, we can say that square is also a parallelogram. Rectangle can also be thought of as a special parallelogram if you see these two, first two. So that means this also holds true.
Yes, ma'am.
Yes, we are saying that square is a special type of rectangle. A rectangle is a special type of parallelogram. So we can say that square is also a special type of parallelogram. Yes. Are you understanding, children?
Yes, ma'am.
Everyone? Yes, Neha, Nishika, Adya.
Yes.
This is all about the properties of quadrilaterals. What we just discussed about. Okay, let's see what the next question is. A figure is said to be irregular if its sides are equal in length and angles are equal in measure. Can you identify the regular quadrilateral? Okay, now I have told you regular figure is that figure which has all sides equal, right? All sides are equal, all angles are equal. If I have to take a triangle, so it's all sides are equal, all angles are equal. Now it's saying take a regular quadrilateral. So what regular quadrilateral will I take?
And square.
Yes, so it's a square. Okay, regular quadrilateral. All angles are 90 degrees. All angles are equal and all sides are equal. Okay, so next is angle, quadrilateral, and head figure. Okay, so these are some curves here. Name each polygon. Can you name the polygons? See this one, first one. Second question I'm talking about.
Fine.
It's a kite. Okay.
Yes, ma'am.
Okay, this figure is a triangle. You all know. This is how many sides are here. Just check the sides and name it. It's a
Pentagon.
it's a pentagon. Next one. Next one. Hexagon. It's 1, 2, 3,
Ma'am,
4.
octagon.
1, 2, 3, 4, 5, 6, 7, 8. It's octagon. Okay. It's 8-sided. Okay. Make two more examples of each of these. So can you make any two examples of any of these? If you have to make more,
Yes, ma'am.
just try it. Okay. Take it for homework. You can try it. Draw a rough sketch of a regular hexagon connecting any three of its vertices. Draw a triangle. Identify the type of triangle you have drawn. Okay, now if I make a hexagon, now see when you were doing the symmetry chapter, you were making diagonals, no? Lines of symmetry, how many lines of symmetry are. So it's saying just, it's not that actually, the connecting any three of its vertices. So see three vertices, these three vertices are connected like this, one here, and if I connect like this, I get a triangle here. Identify the type of triangle you have drawn. Now, which triangle is this? Now, I know this is a regular hexagon. Regular hexagons means these two sides will be equal. So that means this triangle which I'm getting with two sides equal is an which triangle? Isosceles. Okay. So this triangle in this two sides are equal. So I call this type of the triangle I have got is isosceles. Okay, draw a rough sketch of a regular octagon. Draw a rectangle by joining exactly 4 of its vertices of a octagon. Octagon is 8-sided figure like this. Okay, and like this. Then take like this and like this. 1, 2, 1, 2, 3, 4, 5, 6, 7. So one more is missing here. One more I need to make. 1 second. I'll make it like this. 1, 2, 3, 4, 5, 6, 7, 8. Now it's octagon, right? So it's saying that if I join the 4 dots, so 2 are already joined here. 2 more if I join like this, right? So if I join the 4 dots, what draw a rectangle by joining exactly 4 of its vertices. Okay, so this is a rectangle I have got. Okay, so this is just yes, good beta, good Shreyansh, very nice. The diagonal is a line segment that joins any two vertices of a polygon and is not a side of a polygon. Draw a rough sketch of a pentagon and draw its diagonals. So if I have to draw the diagonals of a pentagon like this, I can make like this. If I join it like this, I join it like this, I join it like this, I join it like this. Yes, right? Is it? This is the diagonal. If I have to name this figure like this, just name the figure A, B, C, D, E, E. Okay, rough sketch of a point pentagon and draw its diagonal. So like this, I join these two, I join these two, I join these two, I join these two. Okay. I hope you are understanding, children.
Yes, ma'am.
Because we have mostly done this in when we were doing the lines of symmetry, no? Okay, now these are 3D shapes, 3-dimensional. Why do we call it 3-dimensional? Because it has length, breadth, and the third factor is the height. Okay, length, breadth, and height. Normally, for square, rectangle, we were just having length and breadth, right? But here we have a height also. Okay. So now this is, first one is a cuboid, right? So here are some explanations about this. What are faces? What are vertices? What are the edges? Okay. Then you have a prism here. A triangular face is also known as its base. The prism has two identical bases. The other faces are rectangular. Now it's saying for a prism, prism has two triangular bases and the rest of the sides are rectangles. Okay, if you see this, this is a triangular base and the rest of the sides are rectangle. So this side you have a triangle and here also you have a triangle, this side which is hidden, right? But this side of the face and this side of the face is rectangular. Okay, and for a pyramid, what can you say? A pyramid is a shape with a single base. Pyramid has a single base. The other faces are triangles. So if you see, these are all mounted upwards like this. So the sides are all triangular and the base is some quadrilateral. Okay, either it can be a square base or a rectangle base. A base is some quadrilateral and they are all mounted upwards. Okay, the faces are triangles. Are you understanding difference between prism and pyramid? Yes, children?
Ma'am.
In a prism, you have a triangular base and you have two bases and the other sides are rectangles. But in pyramid, you have a single base. Okay, like this. Suppose it's a base and all the sides, if you see like this, these are all mounted like this upwards. Okay, and they meet at one vertex. Okay. Then we have a cylinder, cone, a sphere. This is the last part of the chapter. Okay. Okay, let's see this. Match the following. Now, cone. Okay, this matching thing you can do. What shape is your instrument box? Yes. What shape is your instrument box? You all know.
Rectangle.
Oh, cuboid.
Ma'am. Oh, ma'am, I thought 2D or 3D.
Yes.
Oh, ma'am, I thought you were talking about 2D, ma'am.
No, beta. We are doing 3D shapes. No. So it's a cuboid. Yes. A brick. What is the shape of a brick?
What? A cuboid.
It's a cuboid. A matchbox?
Cuboid.
Cuboid. Road roller? You must have seen when roads are built.
Sir, ma'am.
Cylindrical. Very good.
Cylindrical.
Yes. A sweet laddu.
Cuboid and cubal.
Yes.
Sweet laddu.
Sphere.
Sphere. Okay,
Yeah,
it's a
ma'am.
sphere. Okay. So with this, we end with the chapter. Right?
Yes, ma'am.
Okay. So you all must read this chapter, practice this chapter once again. For your next Sunday test, I'll be giving this chapter. Okay.
Yeah.
So this time you have your integers. So today the class time is over. Nishika will take up your chapter tomorrow. Okay. Yes, Nishika. Nishika is here.
Ma'am, on Sunday we have subjective or objective test, ma'am.
This time you have subjective test.
Okay, ma'am.
Okay. Okay, children. Thank you. Thanks for joining everyone. Bye bye.
Thank you, ma'am. Bye, ma'am.
Bye, beta.